Hey guys, this is 7.4. We are now proving trig identities. That means we're writing, remember in geometry, you used to write proofs with two columns, one on the right and one on the left, and the right column is justification. Well, trig proof, just like what you guys did last year in Algebra 2 trig, you don't really have to justify. You just have to write it in a way where I can follow from one step to the next. Okay, so let's just review some vocabulary here. Two functions, f and g, are said to be identically equal if and only if f of x equals g of x. Okay, so for every value of x for which both functions are defined, such an equation is referred to as an identity. An equation that is not an identity is called a conditional equation. Remember when we had this right here, y equals x? This is called, what do we call this? Remember, if it's an inverse function, we said it has to be symmetrical about the identity line, right? The reason it's called an identity line is every x, okay? So whatever x is, y has to be exactly the same. So same thing with the identity equation. So f of x has to equal to g of x if x is defined for both. So we're going to talk about quotient identities. Tangent of theta equals the sine of theta divided by cosine of theta. Cotangent of theta equals to cosine of theta divided by sine of theta. Okay, so that's a quotient division. These are the reciprocal ones. Cosecant identity, cosecant of theta equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tangent of theta. Those are the reciprocal, which is not the same as inverse, okay? The most important identity is sine squared plus cosine squared equals 1. Okay, this is the most important one. Now, do I have to memorize these two? You don't have to memorize it if you know how you come up with it. So if I divide each and every term by sine squared of theta, okay, sine squared of theta, sine squared of theta, well, sine squared of theta divided by sine squared of theta is 1. Cosine square of theta divided by sine square of theta, that is going to be cotangent square of theta. 1 over sine square is going to be cosecant. So if I go and divide each and every term by sine square, then this is the new identity that I'm going to come up with. Now what if I don't want to divide by sine square of theta? What if I want to go and divide every single term by, let's say, cosine square of theta? Okay, cosine square of theta, cosine square of theta. Okay, so 1 over cosine square of theta is going to be secant square of theta. Cosine square of theta divided by cosine square of theta is going to be 1. Sine square over cosine square is tangent square. So if you go and divide each and every term by sine square or cosine square, you're going to get a new identity. Okay, so my brain is full. Okay, I don't need to memorize stuff if I don't need to. And then remember even and odd. Sine, there were 4 functions that were odd. Okay, sine, its reciprocal, which is cosecant. Then we had tangent and its reciprocal, which is cotangent. These 4s are odd. There were 2 even ones, cosine and secant. Those are 2 even functions. So let's establish some the guidelines for for proving identities. Number 1, it is almost always preferable to start with the side containing the more complicated expression. So if you look at a side that looks scarier, looks longer, that's where you want to start. It's easier to go from larger and more complicated to a simpler and easier expression. Rewrite sums or differences of quotients as a single quotient. Okay, so if you have the reciprocal or something that's divided by something, write it as one answer. Sometimes rewriting one side in terms of sine and cosine functions only will help. Always keep your goals in mind. As you manipulate one side of the expression, you must keep in mind the form of the expression on the other side. Okay, so we're going to start with something that sort of, what do we call it? The example 1 is just kind of like rule of thumbs, or, you know, these are the things that you should try if you're stuck. Okay, so example 1. We will start the process of writing proofs with easy steps or easy problems first. So example 1, I kind of give you hints of what to do. So simplify tangent of theta divided by secant of theta by rewriting each trigonometric function in terms of sine and cosine functions. Okay, and remember this is one of the guidelines, right? It says sometimes rewriting one side in terms of sine and cosine will help. So we're gonna always start with the original problem. So if it's from your textbook, okay, rewrite it. This is your step 1. And you can use bullets or number each step so I can follow it. Okay, preferably numbering. So I can go, hey, I can totally read, right? 1 to 2, 2 to 3. And it says rewrite each trigonometric function in terms of sine and cosine. So tangent of theta is going to be sine of theta divided by cosine of theta. Oops, why do I write 2 thetas? Cosine of theta. Here we go. Oh, that is so gross. All right. So tangent is sine divided by cosine. Then I'm going to do this division right here using 2 dots. Okay. Secant is going to be 1 over cosine of theta. So that's my first step. Then step number 3 is going to multiply by its reciprocal. So sine of theta over cosine of theta times cosine of theta all over 1. As you can tell, these two will cancel each other out. So step 4, since they cancel, I'm going to end up with sine of theta. Alright, so tangent of theta divided by secant of theta simplified down to just sine of theta. This is the last step. Okay, so just really for my own grading purposes, I want you to write your initial. Okay, so A-N-G Tran-Bloom, that's my initial. Okay, so I know that, hey, you know what? I'm done. I'm confident that this is my final, this is the simplest thing I can go, and this is my final answer. Because here's the thing that happens a lot. A lot of students get stuck and they kind of leave it in the middle, and I don't know if they're done or they're stuck. So if you write your initial on it, you own it, right? That means you are completely done. Okay? Let's move on to a couple more. Show that sine of theta divided by 1 over 1, sine of theta divided by 1 plus cosine of theta equals to 1 minus cosine of theta all over sine by, I'm giving you a hint, by multiplying the numerator and denominator by 1 minus cosine of theta. Okay, so what I'm going to do is, here's my original problem, so copy it down. Okay, now when you're copying it down, because you're doing your notes, so it's already in your notes, but most of us are going to be copying from our textbook. So make sure you copy it first before you pick a side. Okay, so here's the original problem. So assuming we're copying this in book. Then the next thing is we're going to do is we're going to pick one side. I'm going to pick this left-hand side. Okay, they're both almost identical. So I'm going to pick the left-hand side, which is sine of theta all over 1 plus cosine of theta. Now, class, you cannot, I'm going to tell you right now, you cannot do both sides at the same time. You can only do one side. If you're going to pick the left, pick the left. If you're going to pick the right, pick the right. Okay? So in this case, I'm picking the left side. And it says I want to multiply numerator and denominator by 1 minus cosine of theta. Okay? You know, let me erase this because I need to multiply. So multiply 1 minus cosine of theta, 1 minus cosine of theta. And again, do not skip step, because don't assume I know what you're thinking in your head. I don't know what you're thinking in your head, right? So what I'm going to do is I'm going to multiply this out. So 1 minus cosine of theta, 1 plus cosine of theta, times 1 minus cosine of theta. Okay, so that's my step number 3. Step number 4, if you look at this, these two are conjugates of each other. So when I multiply them, it's going to be easy. 1 minus cosine square of theta. And this becomes sine of theta times 1 minus cosine of theta. Okay. Now, in the guidelines, it says keep in mind where I want to head to. Okay. So keep in mind I want to head to here, right? I want to make the left equals the right. And the right-hand side has 1 minus cosine on the top. So if I see 1 minus cosine already, sorry, that was the bell to go to 6th period. Alright, so if I see 1 minus cosine in my numerator, I'm not going to try to distribute, because ideally this is what I want to head to. Okay, I want to head to 1 minus cosine. Now my goal is, how do I get rid of this sign on the bottom and make this into make this into just simply sine. So that's where my next step is, my step number 5. Okay, so I'm going to rewrite the numerator. Sine of theta times 1 minus cosine of theta all over. Now, 1 minus cosine square of theta turns itself into sine square of theta. And here's where I'm going to write my identity so the teacher knows what I'm using. Sine square of theta plus cosine square of theta equals 1. Okay, this is when I'm using my identity and not just algebra. So, the Pythagoras said sine square plus cosine square equals 1. Okay, but I have 1 minus cosine, so how does that turn itself into sine square? Well, if I subtract both sides by cosine square, then it becomes 1 minus cosine square equals sine square, right? So that's why it's turning itself into sine square. Then step number 6, sine, and one of these is going to cancel, so I'm going to end up with 1 minus cosine of theta all over sine of theta. This is the end. Do not go any further, because remember, my goal is just to try to get to the other side. So since I've chosen the left, this looks exactly like the right, so I can stop. And since I'm done and I'm positive I'm right, I can write my initial to tell the teacher that I'm done. Alright. So in a little bit, if time permits, I'm going to write the proof using the left-hand side as well. But right now, we're just going to keep on going until we're done. Okay. Example C. Simplify 1 over 1 minus sine of u plus 1 over 1 plus sine of u by rewriting the expression over a common denominator. Okay, and that's a great idea. So step 1, write the problem from your book over, or in this case, it's from your notes. Copy it over anyway. Okay. So step number 2, common denominator tells me that I would multiply these two together. So 1 minus sine of u times 1 plus sine of u. What I multiply on this side is 1 plus sine of u, so I'm going to multiply the top by 1 plus sine of u. Over here, I'm going to multiply top and bottom by 1 minus sine of u. So I'm going to multiply the top by 1 minus sine of u. Okay. Alright. Since the common denominator are now identical, I can put the top together. So 1 plus sine of u plus 1 minus sine of u. I'm going to multiply those out. It's going to give me 1 minus sine square of u. And from here, let's see if I can combine like terms. Oops, you can't really see it. There you go. From here, I'm going to see if I can combine like terms. 1 plus 1 is going to be 2. Sine of u minus sine of u, that's going to be gone. So now I have 2 over 1 minus sine square of u. Okay. Well, 1 minus sine square of u, I'm going to use an identity here. And I'm going to change that to cosine square of u. And the identity I'm using is sine square of u plus cosine square of u equals 1. Okay, and the reason how that works is if I use this Pythagorean theorem identity, if I subtract both sides by sine square of u, then it becomes cosine square of u equals 1 minus sine square of u. That's why I can substitute this for cosine square of u. On the top, I'm just going to end up with 2, and this is my step number 5. Step number 6, again, this is a fraction, which is not the simplest form. So I'm going to write 2 times 1 over cosine square of u. Would you agree with that's the same? And step number 7, 1 over cosine square of u is going to be the 2 times secant square of u. And since this is the simplest form, this is not a fraction, so I'm going to stop right here. You always try, when it says simplify, you always try to go as far as possible with no fraction, if possible. Okay, because if it's a fraction, you can always convert it back to its reciprocal form. Okay, alright. Example D, simplify again, so hopefully, let's see how that will go. Okay, your goal is try to get it as in non-fraction format, if possible. Okay, there's always a way to get into non-fraction. Okay, so I'm gonna do is that, hey, I'm giving you a hint by factoring, and yes, you can factor out trigonometric functions. So step 1, copy the problem over. So 1 minus cosine square of v divided by sine of v plus cosine of v times sine of v. Okay, keep extending my division line. 2. Factoring sets. This is going to be, can I factor 1 minus cosine square of v? Sure. It's going to be 1 minus cosine of v times 1 plus cosine of v. This one looks like I have sine of v in common, so pull that out. If I pull out sine of v, this is 1. If I pull sine of v, this becomes cosine of v. Okay. And step 3, yes, you can totally reduce. Those two are reducible. So now I'm going to have a 1 minus cosine of v all over sine of v. Alright, now this is still in a fraction format, which is not quite as cute, so we're going to rewrite it so we get into a non-fraction format. So this is all over one denominator, which I can go backwards and put it like this. Okay, 1 over sine of v minus cosine of v over sine of v. Your goal is to, when you simplify, get into a non-fraction. 1 over sine of v is the reciprocal function, so step number 5, that's going to be cosecant of v. Cosine of v over sine of v is a cotangent of v. And this is the simplest form we can go. It's not a fraction anymore, and since it's not a fraction, I'm going to say, hey, you know what? That's the best I can do. Okay, so let's recap, okay? In terms of writing proofs, or showing that the two identities are, okay, sorry, that's the bell for tardy 6th period. So in terms of writing proofs, there are a couple things you can do. You can factor out your expressions. You can rewrite over a common denominator when possible. You can multiply the numerator and denominator by its conjugate, okay? So the conjugate of 1 plus cosine theta is 1 minus cosine theta. I can choose the right-hand side and multiply by its conjugate, which is 1 plus, so it depends on which side you pick. And another reminder of some tricks or guidelines is you can also write it in terms of sine and cosine functions. Okay, so those are pretty much all the things you can do. Alright, so now let's move on to actually doing it, okay, doing it by hand. And I'm writing like a paragraph here telling you that there's really no easy way for you to learn this. I can't teach you how to. There's not a one right way. You guys are all gonna have your own way of writing proofs, okay? And on there's 26 of you, or 36 of you, or 37 of you in a class. I'm gonna have all different ways of writing proofs. Some will pick the right side, some will pick the left side. And so make sure that when you're writing proofs, you're writing it neatly, and don't assume I know what you are thinking about, because I don't, okay? So you have to write it all out, okay? Alright, so remember the guideline said make sure you pick the most difficult side and start with that side, okay? So step 1, copy the problem over from your textbook. So I understand that this is your notes, but let's just try to get into the good pattern of writing this. Okay, so this whole thing is the problem of the book. I'm going to pick the left side, because that looks a lot more difficult than picking the right. So this is the left side. I'm trying to prove, okay, that sine times a quantity of cotangent of theta plus tangent theta, it's going to come out to be secant. Okay, and some of you would do it in 5 steps. Some of you do it in 15. So again, as long as you can write every single thing and I can follow it, the moment I write a question mark on it, then I'm going to stop and not give you any more credit. Okay, and no, you can't come to me and explain to me. I'm not going to have time for a class to come and individually explain stuff. You just have to write it down. Okay, so the first thing is, I'm going to use one of the guidelines. This one has sine, this one doesn't. Okay, so I'm going to start converting all of this into sine and cosine. Oh, I'm sorry, this is step 2. This is step 3. So sine of theta times cotangent is cosine of theta times sine of theta. Tangent of theta is going to be sine of theta times cosine of theta. Okay. Alright, so the next thing is in your guidelines is it said, hey, you know what? When you're adding fraction, try to find the common denominator. So that's what I'm going to do. So sine of theta stays outside. Common denominator, let's see. Okay, multiply those. So this is sine of theta times cosine of theta. Sine of theta times cosine of theta. That's the common denominator. Over here, I'm going to multiply the top by cosine. So times cosine is cosine square of theta. Over here, I'm missing a sine, so multiply the top by sine. Sine squared times sine square. I'm sorry, sine times sine, sine square. Oh, okay. So look at this. So now the denominator are the same. I'm going to put it over one denominator. Okay. So sine of theta, cosine of theta, cosine square, plus sine square of theta. Okay. Oh, this is awesome. Isn't that beautiful right there? What am I using? What identity am I using for that one? So I'm going to write sine of theta times 1 over sine of theta times cosine of theta, right? So I'm going to need to write my identity. I'm using the sine square of theta plus cosine square of theta equals 1. Yay! Okay. That turned itself into that. So from here, I'm going to proceed. This is sort of saying sine over 1. So sine over 1 cancel with that. I'm going to end up with step number 6, which is 1 over cosine of theta. Because these two can be canceled. Well, keep in mind my goal. My goal is to get to secant of theta, which I'm actually one step shy from completing my goal, right? So initial, and so I know I'm done. That's what happens when you write a proof. Okay, so now we're going to do hopefully one more, and then, alright. And again, if you didn't get that, I'm using a lot of guidelines, okay? The guidelines that it was initially at the notes, I'm using a lot of it to complete my proof. So, letter B. Letter B, which side is more difficult? The cosecant of theta minus cosine of tangent, or the sine over 1 plus cosine of theta? Usually you guys pick the fraction one, right? So we're going to write this original piece, okay, because we're going to assume that this is from your textbook, and I don't know what's written in your textbook. Right. So here's from your textbook. Except the next step, I'm going to pick this side, the right-hand side, the fraction one. Okay? I'm going to pick the fraction one. And on the next step, after copying from your book, just pick the side. Then step 3 is when you can come in and do stuff to it. Okay? So, for example, I'm going to multiply the top and bottom by the conjugate. And let's see if that will work. And sometimes it doesn't work. And if it doesn't work, I'm doing this without any solution manual help. So, and sometimes it doesn't work. If it doesn't work, then we just have to erase and start all over again. So hopefully you guys are using your pencil when you're doing your homework. Okay, so the conjugate says I'm going to multiply this by 1 minus cosine of theta. So sine times 1 minus cosine of theta all over. These two are conjugate of each other, so it becomes 1 minus cosine square of theta. So that's what I'm trying. Now the next step is, let's see, can I do anything with this? I can convert this into sine square of theta, right? I'm going to leave. What happened if I distribute? Can I distribute? Because remember, keep in mind my goal. My goal is to get to 1 minus cosine of theta. So I can distribute because I don't need to keep 1 minus cosine of theta. So sine times 1 is sine of theta. Oops, sorry. Can you put sine of theta there? Sine of theta times 1 is sine of theta. Sine of theta times negative is going to be sine of theta. Negative sine of theta, cosine of theta. Just distributing the sine of theta. Now, how did I get the sine square of theta there all of a sudden? I'm using my identity, right? Sine square of theta plus cosine square of theta equals 1. That's what I'm using. Then the next step I'm going to use is, what can I do? My goal is to get to cosecant and cotangent. So from here, how about I'm going to split this up into two terms. Sine of theta all over sine square of theta minus sine of theta cosine of theta all over sine square of theta. Okay. Notice how when you have a subtraction or addition on the numerator and you have one denominator, you can make into two terms. So technically these are just over the common denominator of sine squared. Okay, so from here I'm going to reduce. So that's step 6. Oops, nope, that's 5. This is 6. So this is 7. So step 7, I'm going to reduce 1 over sine of theta. That's what I'm going to reduce it to. One of this is going to cancel, so minus cosine of theta over sine of theta. Okay, keep in mind my goal. I want to get to cosecant. So is that going to give me cosecant? You betcha. Oops, I wrote secant. See, look at that. This is going to get to cosecant of theta. Is that going to give me cotangent? Yes, it does. Okay. So since I have achieved my left-hand side, I'm going to own it by initial my work. Alright, and this is the end of our video notes for today. I'll see you guys next time.